Hey guys, and welcome back to this new video. Today let's take a look at this Wi-Fi or network enabled flip counter. Let's call it the shitty counter, because not only can you count your toilet usage with it now, but it's also way overpriced. Let's take a look on how to reuse it and how to bypass their cloud system, this smiirl one. And let's take a look inside and how to control it basically. First of all, I can really not suggest on getting one because it's just way overpriced, and I was just lucky to get one for like 20 euros from the local flea market. And yeah, we'll now reuse it as the shitty counter. So let's start by taking a look at what it can do now. So let's put this near the toilet and the counter as well. And every time you're finished, you can just increase the counter. And the other shitty part is really like the price, because this smiirl company asked for 300 euros if it's just a regular subscriber counter, or even 100 euros more if you want to customize your countings, which is just ridiculous to just enable an API call for 100 euros. While even having such a bad cloud security, which I will not go further into, but yeah, I would not suggest to take a deeper look or even get one of these counters. Since this is quite the simple use case, I made another one. If you press and hold the button for a few seconds, it will switch to clock mode and will then simply show the current time. So you have the nicely flip noise. Like so. And every minute it will increase, of course. It's, quite usable this way, but not if you pay 300 euros for it. The way this works now is we are a Home Assistant and a Node-RED flow, which just basically gets the switch, the push button trigger, creates the API call to the correct one, which is actually quite simple to do. If the flip counter is in your Wi-Fi, you just use this URL and can enter any number you want here. So let's just use this. And if it's called, it will just do this. And other than that, it's not only that this is without any security. I mean, okay, you are in the same network, but by accessing this endpoint, you will also be able to enable SSH, and the returning password can be used to then log into the device and have full root access, which is quite nice. So you can really play around in depth and dump out everything you want. Internally, the cloud system they use is like a Lua script, which makes basic HTTP requests to the cloud. So you could even just do an reassigning entry to get every request into the cloud to your own server, to also bypass their system basically. And other than that, let's take a look inside. One note before that, they have two versions of this. The older one, which uses like OpenWRT or OpenWRT and a full Linux system, and the newer version uses an ESP32, but it also seems to be the same API calls internally, so you can just reuse what I do now, just not the Linux shell you will get. And to open it up, let's build the table a bit better. And just to also take a look at the outside ones. On this version you have the network entry point, and you now have my MAC address, but I will not reuse it anyway. And yeah, the case itself is basically like just clipped in from the front, and everything else is one part. To open it up, we can just use an X-Acto knife or any flat device to basically pull out the front and go around the case. Let's also do this from this side. And like so. And after enough clips are apart from each other, it should be quite easy to basically lift up the front. Like so. And now the wooden panel can also be extracted or moved out. This seems to be printed on the wood, so if you want to remove it and make another logo there, it needs to be, yeah, also maybe a sticker, or like here, this 3D printed part. You can unfortunately not just turn the wood around, because these clips are there to prevent the flips from over flipping. And other than that, you now have here the flip modules, which are really modular, so they are just plugged into each other. They have an I2C interface on each, and the cheapest stepper motor you know of. And also they use some kind of calibration to know where each number is, which of course they need to know. And this main board is then actually just connecting, I think, 5 volts and an I2C bus in series to every, in parallel to every flip counter. And here you just have this Linux Open WRT board. It's very simple in the end, and that's basically everything there is to this teardown already. You have a UART interface on this one. On the ESP32 you will also have it, of course. And other than that, we can just close it again. Like so. And plug the power cable in and wait for it to boot. It needs to stand upright, because otherwise the flips would not work correctly. In the background it is now rebooting and starting the OpenWRT system, the Linux system. I have also seen that the whole OpenWRT system is also basically available, and you can do the same WRT settings as you would in any other system. And it's now calibrating on boot to the correct numbers, which hopefully does work after opening it up. Otherwise there is a hidden menu to also calibrate these flips again. And looks like the clock script is now actually running already, so we will see some misbehavior here, but overall it will work out. And that fits. So here the 4 is now missing and the 1, because both programs tried to run a number at the same time. So you need to throttle this call for minimum 30 seconds roundabout, otherwise it will get missed numbers. But in a moment it should show the correct one again. And that's basically it already. It's a nice flip display overall, if not so bound to their cloud, which is really the bad part. And it's, yeah, nice to hear it flipping. Okay.